Hi guys, this is Dr. G here, and in this particular video we will talk about SI units or International System of Units. So basically for most students who are especially from America could have an adaptive period to these SI units, mainly because in US we use something called US units, or in other words, when we measure certain things in mass or things in volume, we measure units that are somewhat different from these international system of units. So some people might be a little bit familiar with these units, some are not. So that is why I decided to post a video on SI units, mainly because SI units are the units that we will use in sciences. So in chemistry we will specially try to stick to SI units when we are doing calculations and sample problems in chemistry. So uh, if you are measuring a physical quantity mass, the SI unit is known as kilogram. SI unit is known as kilogram. And then if you are measuring a physical quantity such as length, the SI unit that we use is something called meter. Meter. And the abbreviation for meter is lowercase m. And then if you are measuring time, of course you already know that the unit name is seconds. uh, Temperature is measured in Kelvin. This is actually a drastically different measurement as compared to Fahrenheit that we use to measure temperature in US. And then to measure electric current we use ampere, and the unit abbreviation is uppercase A. And then amount of substance is measured in mole, and we will actually talk about this particular physical quantity in much more detail in later chapters. But in chemistry it is very important to have a good understanding on how to use the term called mole. Okay, all right. So then luminosity is actually measured in candela. Okay, the unit abbreviation is CD. So I would recommend that you guys at least remember the unit abbreviations for kilogram, I mean mass, length, and of course time, temperature, and also uh, amount of substance. These five unit abbreviations will be very important, when doing chemistry based calculations. Okay, so we use kilograms to measure mass. Okay, uh, meters to measure length, and then seconds to measure time, Kelvin to measure temperature, and then mole to measure amount of substance. So these are SI units that we usually use in chemistry. And the good thing about these SI units is that whenever we want to modify our unit, we can simply use a prefix and make our unit a smaller unit or a larger unit. As an example, let's say you are measuring the length of a table. Okay, you might measure the length of a table in US units, feet, okay, or inches. Okay, and then you can easily measure the length of a table. But let's say you are measuring the distance between Tuscaloosa and Hoover. Okay, then you might not want to measure the distance in feet or inches. Instead we may use miles. Okay, you can communicate the distance between Tuscaloosa and Hoover in or Birmingham in miles. So basically we usually change the unit that we need for a measurement based on the size of the measurement. The good thing about these SI units is that whenever we want to have a smaller unit or a larger unit, rather than inventing something out of the sky, we use common decimal prefixes to modify the same exact SI units. So the first thing that I want you to do is I want you to remember this table. I want you to remember this table, at least the numerical values and the prefix symbol. Okay, so right here you have the prefix symbol. Okay, so remember prefix symbol, and then I want you to remember the exponential notation or the conventional notation of that particular prefix symbol, because these symbols are going to be extremely important when doing SI unit based calculations. And in fact, if you remember this table, it is going to be very easy to convert between two different units. Okay, all right, so let's take a look at this units. So basically the regular SI unit is going to be here, okay, in the middle right here. Okay, so it could be meter, it could be gram, it could be any SI unit. Okay, it could be any SI unit. So basically this will be your regular unit without any prefixes. And then when you are going down, the size of the unit is getting smaller. Why? Because you are going to use a prefix like, as an example, let's take milli. Okay, and then milli has 10 to the power minus 3, or you can say 0.001 value. Okay, so you are basically making the SI unit smaller when you are going down. Okay, so when you are going down this table, the SI unit is getting smaller. Okay, or in other words, these prefixes have a value that is less than 1. So you are multiplying the prefix SI units by a value that is less than 1, so the value of the unit will become smaller. Okay, and when you are going up, the size of the unit, or you are increasing the size of the unit. Okay, so your unit will become larger. The unit will become larger. Okay, so that is how you do it. So kilo, okay, as an example, will multiply the SI unit by 1000. Okay, will multiply the unit by 1000. Okay, so this is how you usually use a prefix table when modifying an SI unit. Okay, let's do an example. Okay, so let's do an example that is familiar to you. Okay, let's use US units and then see what we could do. Okay, so as an example, let's see if we could convert 3 feet into inches. Okay, so see if you could convert 3 feet into inches. Okay, when you are converting a certain number of feet into inches, you want to know the relationship between feet and inches. So the relationship between feet and inches is, of course, 1 feet is equal to 12 inches. Okay, 1 feet is equal to 12 inches. So you are going to use this relationship, this particular relationship between feet and inches in order to convert 3 feet into inches. 3 feet into inches. How do you do that? So you basically, when you have a relationship, what you do is you will try to make a conversion factor. Okay, you will try to make a conversion. Of course, most people can do this in their head. Okay, I'm not talking about the people who could do this in their head. I'm talking about the people who might need some help doing these calculations. Okay, so when you have a relationship between two different species, you will develop two conversion factors. This is how you do it. You will put one term on top and the other term at the bottom. Okay, other term at the bottom. So this is inch. Or you can keep 12 inches on top and then 1 feet at the bottom. All right, so these are the two conversion factors. Okay, these are the two conversion factors that we can develop from the unit relationship that we have. Okay, so now what we need to do is we need to convert 3 feet into inches. So by using one of these two conversion factors, you have to convert 3 feet into inches. Okay, you have to convert 3 feet into inches. So which conversion factor will you use? This is the most important part. Which conversion factor will you use to convert 3 feet into inches? Okay, so basically we will use the conversion factor that has the units of our answer on top. Okay, so inch should be on top and then feet should be at the bottom. Okay, inch should be on top, feet should be at the bottom, and then of course the conversion factor that matches this is going to be B. Okay, so we will use B in order to do this conversion. So 12 will be on top, 1 will be at the bottom. So why did we use feet at the bottom? Because feet to feet will cancel out, feet to feet will cancel out. So your answer will be in inches. So 3 times 12 is how much? 36 inches. 36 inches. Okay, so the answer is 36. This is how you do a unit conversion in US units. But let's try one using SI units. Let's say you have 1.20 kilograms of something. Okay, some matter. Okay, and how much will this be? In grams? In grams. Okay, this is the conversion that we need to do in this particular problem. Okay, what we have is kilograms. Okay, you need to convert it into what? Into grams. What we need is kilograms and we will convert it into grams. So to do these conversions, only thing that you need is the numerical value of the prefix used. So the prefix that is used in this calculation is of course kilo. So you look at the decimal table or the prefix table and you realize that kilo is what? Kilo is 1000. Okay, kilo is 1000. So when you are converting this particular calculation, when you are calculating or converting this particular calculation, what you could do is you can replace kilo. Okay, you can replace kilo with the numerical value of kilo. Okay, so the numerical value of kilo is what? 10 to the power 3. So the answer will be 1.20 times 10 to the power 3 grams. Okay, the answer will be 1.20 times 10 to the power 3 grams, or it is the same as 1200. It is the same as 1200 grams. Okay, this is one way to do it. How did I do it? I simply replaced the prefix. Which is this one. I replaced the prefix with its numerical value, which is 10 to the power 3. Okay, that is how you do this. Alright guys, so there is another way to do this. There is also another way to do this, which is the conversion factors. Okay, so the conversion factors are of course kilo equals 10 to the power 3. Okay, kilo equals 10 to the power 3. Okay, this is the relationship that we need. We read it from the table that I have given you and you will memorize it, of course. Okay, and then basically we will develop two conversion factors out of it. In 1 kilo divided by 10 to the power 3, and the other conversion factor will be 10 to the power 3 is divided by k. Okay, so these are the two conversion factors for kilo. Okay, these are the two conversion factors for kilo. So let's do another calculation. Okay, let's do the same calculation. Okay, what you have is 1.20 kilograms. You want to convert it into what? You want to convert it into grams. Okay, you want to convert it into grams. So to do that, what you do is you take the value that you already have and you multiply it by one of these two conversion factors. So which one should we use? We should use the conversion factor that will cancel out kilo, because see, in this side, in the left side we have kilo, in the right side we don't have a kilo. Okay, so we want to cancel kilo out, right? So we want to cancel kilo out. So when we are picking the conversion factor, when we are picking the conversion factor, we must be able to cancel out kilo. And of course, if you want to do that, the top term will be 10 to the power 3. The top term will be 10 to the power 3. Okay, 10 to the power 3, and therefore kilo to kilo will cancel out, and your answer will be in grams. Kilos to kilos will cancel out, and then your answer will be in grams, and it will be 1.20 times 10 to the power 3 grams. Okay, all right. So let's do another one. Let's say you have 384 grams. You want to convert it into kilograms. See if you could do this. You might want to pause the video and try it before I explain it. Okay, so you want to convert this gram value into kilograms, and of course we know that kilo is 10 to the power 3. This is the relationship that we will use. And when we are doing this conversion, we wanna add the prefix k to our final unit. Okay, so you will use the conversion factor that has k on top and the numerical value at the bottom. Okay, so basically this will give you kilogram in one side, and of course 385 will be divided by 1000, which means it will be 0.384 kilograms. Okay, so we did these calculations for grams up until now, okay, which is basically a unit for mass. Okay, so let's see if you could do a few calculations for length. Okay, so let's see if you could convert 183 centimeters into meters. This is your first calculation. Try if you could do this one. Convert 183 centimeters into meters. And secondly, you can try this. You can try to convert 2.5 kilometers into meters. This is actually the second one. And last, see if you could do 1680 meters into kilometers. See if you could do these three calculations. Pause the video and try it. Okay, all right, so let's try the first one. You look at the if you don't remember what is centi, you look at the table and you figure out that okay, centi is what, 10 to the power minus 2. Okay, and then of course the two conversion factors that you need is c divided by 10 to the power minus 2 or 10 to the power minus 2 divided by c. Okay, 10 to the power divided by 2. So these are the two conversion factors you will use for this particular calculation. And then what you have is 183 centimeters, and of course you want to get rid of this centi, okay, because the final unit is going to be in meters. So if you want to get rid of centi, you should put c at the bottom so you can cross it off, and then 10 to the power minus 2 should be on top. 10 to the power minus 2 should be on top. Okay, so centi to centi will cancel out, and then you will multiply 183 by 10 to the power minus 2, so your answer will be 1.83 meters, 1.83 meters. Okay, and 2.5 kilometers. Of course, we talked about kilo. Now you know what kilo is. Kilo is 10 to the power 3. Okay, so you want to get rid of kilo, right? You want to get rid of kilo. Okay, so you will multiply it by 1000, which is actually this is 2.5, excuse me, which is 2500 meters. Of course, if you have a hard time doing these calculations, do them using a calculator. Okay, and once again, in here you want to convert meters into kilometers, so what you do is you will add kilo into this calculation. So if you want to add kilo as a prefix, okay, use this conversion factor, kilo on top, 10 to the power 3 at the bottom, because you are adding kilo to the final answer. Okay, adding kilo to the final answer, so it will be what, 1.680 kilometers. 1.680 kilometers. All right, let's do one more simple calculation. Let's see if you could convert 0.000634 liters into microliters. See if you could do this one. Try to convert 0.000634 liters into microliters. Okay, pause the video and try it, of course. And the relationship between what is micro? You look at the table and you realize that micro is what, 10 to the power minus 6. Okay, so this is all we need. And of course, develop two conversion factors. 10 to the power minus 6 could be on top in one and micro at the bottom, or micro could be on top and 10 to the power minus 6 at the top. So these are the two conversion factors that we need. But of course, in our answer we are adding micro, so you have to have micro on top. So the conversion factor, the correct conversion factor is this one. Okay, this is the conversion factor we need. All right, so we know that. So let's do this. Okay, oops, excuse me guys. All right, so what we have is 0.000634 liters. You multiply it by micro divided by 10 to the power minus 6. Okay, and then your answer will be in microliters, and when you do this calculation it will be 634 microliters. All right, so this is how you do it. All right, so this is all I need to talk about SI units, or at least the theoretical part. Okay, so you should be able to go back and forth between two SI units easily using the prefix table. So the first thing that I need you to do is actually figure out or remember the table so that you can use it easily. Okay, and then apply the concept in calculations. Okay, all right, let's go back to our lesson. Okay, so remember this table. With that being said, I want you to I have actually highlighted a few SI units that are very commonly used, especially in chemistry. We use these 5 SI units and these 4 SI units very commonly. Okay, we use them very commonly, so at least remember these and you will be fine. Okay, and I have seen certain ways to easily remember this table. Okay, so you might want to refer to those as well. And most people are very good with computers. So if you remember the bytes and kilobyte relationship, okay, so basically kilobyte is 1000 bytes. Okay, so let's say this is bytes. I mean, kilobyte is like what, 1023 bytes, right? So kilo is usually like what, 1000. Okay, and megabytes is what? Okay, 1000 kilobytes, right? So that is 10 to the power 6, and then gigabyte is 1000 megabytes, so that is 10 to the power minus 9. And then terabyte, which is usually the hard drives these days, that is actually 1000 gigabytes, right? So that is 10 to the power 12. So you may already know this tera, giga, mega, kilo from computer knowledge. Okay, so all you need to remember are the ones that are at the bottom, I guess. All right, so there are easy ways to remember these. So play with this table for a few minutes and you will figure out easy ways to remember it. So don't complain me that, okay, oh my god, this is a table, I couldn't remember so many numbers. No, it is not. Okay, it is easy to remember more than you think. All right, so let's go to the next slide. I think in the next slide I have a small table that basically shows you how to do conversions. Okay, so I mean you can take a look at these tables later on in more detail. Okay, but usually these tables also gives you certain relationships between US units and SI units. Okay, US units and SI units. So basically the relationship between, let's say, a meter and a yard. Okay, meter and a yard is actually very similar in length. Okay, a meter is actually about 3 inches longer than a yard. Okay, and then of course here I have the relationship between miles and kilometers. Okay, so these things could be helpful to you, especially when you are going between US units and SI units. But of course in the exam I will give you these relationships most of the times, because you don't have to remember the relationship between US units and SI units. I will tell you the relationship. Okay, I will try to give you the relationship in the exam. But I mean, take a look at these conversions. It might be very helpful to you. Okay, and one thing that we very commonly use is the relationship between inches and centimeters. Actually 1 inch is about 2.54 centimeters. 1 inch is about 2.54 centimeters exactly. Okay, so this is something that you might want to remember because it is very common. Okay, and the other thing, I mean, there are some more relationships, especially for volume. Okay, here I'm comparing the volume of cubic meters into cubic feet. Okay, so I mean, you don't have to remember them, just take a look at how I did them. Okay, how I did them, but especially I want you to remember this. Okay, I want you to remember this. 1 cubic centimeter is actually 1 milliliter. Remember that. Okay, that is a very common relationship. You should remember this. 1 cubic centimeter is 1 milliliter. Okay, 1 milliliter. That is important to remember. Okay, because this is very commonly used in chemistry. Okay, or you can say 1 deciliter, 1 cubic decimeter. Okay, is actually 1 liter. Okay, see if you could figure out these relationships by yourself. Okay, because these two are very commonly used in chemistry, especially for volume. These two relationships are very commonly used. Alright, these are some of the mass units. Okay, I'm not going to spend all the time explaining you all these things. Okay, but usually the SI unit that we use for mass is pounds or lobes. Okay, as compared to kilograms, but kilograms is actually a little bit bigger unit as compared to pounds. Okay, 1 kilogram is 2.205 pounds. Okay, 1 kilogram is 2.205 lobes. But of course, when I'm giving you quizzes, if I forget to give you these relationships, you can come and revisit these slides, because your quizzes are going to be open book. Okay, so if I ever forget to give you the relationships in the quizzes, you can come and take a look at these slides if you want to. Okay, but these are very common things. You may want to remember them, but it is not necessary. Okay, all right, so with that we will do a small calculation and see if you could do some small conversions and then apply these unit conversions into small mathematical calculations. All right, so I want you to pause the video now and then see if you could do this by yourself. All right. Okay, so what we have here is an irregularly shaped mineral or a rock, okay, a piece of galena or lead. Yeah, we have a piece of galena. Okay, and then we have to determine the volume of that piece of galena. Okay, so if you want to determine the volume of a irregularly shaped object, if you remember the Archimedes findings, okay, you remember the story about Archimedes running around the city naked, screaming "Eureka, Eureka!" when the day he figured out this method. Okay, so if you don't remember the history, go back and look at those stories. They're very funny. Okay, but I'm not going to do these stories like in regular classes in videos, because videos could be really long and boring with all these stories. So please just Google and see if you could figure them out. Okay, but of course, if you have a irregularly shaped object like this, okay, figuring out the volume mathematically could be difficult because of the shape, of course. So what you need to do to get the volume of an irregularly shaped object is that you wanna put it into a container with known amount of liquid in it. Okay, you should know the volume of the liquid. Okay, once you put it in the container, of course, what happens is that due to the presence of the object, the volume of the liquid will go up, or in other words, the volume of liquid will be displaced by this object, and of course the displaced volume, okay, is actually equal to the volume of the object, of the irregularly shaped object. So displacement of liquid or the increase in liquid is actually equal to the volume of the irregularly shaped object. So that is the concept that is used in this calculation. So what is the change in volume? Okay, what is the change in volume here? What we have here is 24.5 is the final volume, okay, and it is in milliliters, and then initial volume is what? 19.9 milliliters. Okay, so you do the math, and then what will be the volume? Okay, I don't have a calculator, but I mean you should be able to use a calculator. And excuse me. All right, so 24.5 minus 19.9, so it will be 4.6 milliliters. So this is the volume displacement, or the volume of the piece of galena. But they're asking for the volume in what? In cubic centimeters. Of course, we just learned that 1 milliliter is equal to what? 1 cubic centimeter. Okay, so 4.6 milliliters is the same as what? 4.6 cubic centimeters. Okay, so we figured out the volume of the piece of galena in cubic centimeters. Okay, and also they want us to give the volume in what? In liters. Okay, so we know the milliliter value. We know that it is 4.6 milliliters. They want us to convert it into liters. Of course, milli is what? Milli is 10 to the power minus 3. Okay, so in this units, in this conversion, we want to get rid of milli, so milli should be at the bottom and 10 to the power 3 should be on the top, right? So you will multiply 4.6 from 10 to the power minus 3 divided by meters. This is your conversion factor, of course, and then milliliters. Milli to milli will cancel out, okay, and then you are multiplying 4.6 by 10 to the power minus 3. So the answer will be 4.6 times 10 to the power 3 liters. 4.6 times 10 to the power 3 liters. Okay, so this is the answer. I think I also have the typed answer because some people like to see the typed answer. Okay, and of course this is the plan to do this. Okay, I explained the plan to you already. Okay, you will convert cubic centimeters of volume of galena into milliliter. I mean, you will have the volume in milliliters, you will convert it into cubic centimeters and also into liters. All right, so to do the conversion between milliliters to cubic centimeters, you will use this relationship right here. For the milliliter to liter relationship conversion, you will use this relationship right here. Okay, and this will be the solution. You figure out the volume of the galena in milliliters, which is basically the volume of the galena in cubic centimeters, and then you will convert milliliters into liters. Okay, all right, so this will be your answer. Okay, so now let's try this particular calculation. These type of calculations will be very common in your exam. Okay, you will have about 3-4 calculations like this in the exam. Not this hard, I would say. They will be a little bit easier because it is an exam, but I mean these type of calculations should be easy for you. Okay, take your time and then see if you could figure out this sample problem. Pause the video and try it by yourself. All right, so in this calculation what they do is they're trying to lay optical fiber, okay, between two cities, New York and Paris. Okay, all right, so you are trying to lay down a cable between New York, okay, New York and Paris. Okay, pardon my poor drawing habits, I'm just trying to make this calculation easy for you. So if you are laying down cable, the first thing that you need is the distance between the two cities. Is it given? It should be given. Okay, it is 8.84 times 10 to the power 3 kilometers. That is given. Perfect. The length is given. And then they have also given us the weight of the optical fiber, okay, which is basically 1.19 times 10 to the power minus 3 lobes. But this weight is for what? This mass is for 1 meter. Okay, all right, we know the mass of optical fiber at least per meter. So if we know the meter length, we can easily figure out the mass, right, by multiplying this multiplying with 1.19 times 10 to the power minus 3. So we know that. And then there's a curveball in this one. They also say that one cable will not work. You have to have six strands. Okay, so you are basically laying 6 cables. Okay, a bundle of 6. Okay, okay, so basically when it comes to the length of the cable, you take the distance between the two cities and then what, you multiply it by 6. Okay, so let's try to do this calculation. Okay, so length of cable, I mean it could have easily been 8.84 times 10 to the power 3 kilometers, but unfortunately they want us to lay 6 strands of cable, so multiply it by 6. Okay, so once again I don't have a calculator, which is a good thing. Okay, you don't want to do all the calculations one by one. You want to keep all your calculations to the end, so try to do the calculations the way that I do it. Okay, so the length of the cable is what, 8.84 times 6 times 10 to the power 3 kilometers, but I need it in meters. Why do I need it in meters? Because of the mass of cables. It is given in mass in meters, right? So you want to convert kilometers, you want to convert these kilometers into meters. So if you want to convert kilometers into meters, you want to get rid of kilo. Okay, you want to get rid of kilo, so you substitute kilo with the numerical value of kilo. Okay, meters. So this will be the length of cable. Alright, we know the length of cable, which is perfect, and then we want to calculate the mass of cable. Alright, so let's calculate the mass of cable. Mass of cable is, how do you do that? you multiply the length of cable, which is 8.84 times 6 times 10 to the power 6 meters by the mass, 1.19 times 10 to the power minus 3 lobes divided by meters. And as you can see, meters to meters will cancel out, and your final answer will be in what? The final answer will be in lobes. Final answer will be in lobes. Okay, but here's the problem: you don't need it in lobes. You want it in kilograms, I think. Yeah, they're asking for the total mass in kilograms, so you want to convert lobes into kilograms. Okay, we can do that. Mass of cable. Oh, let me. Mass of cable in kilograms. This is easy, not that hard. So you have 8.84 times 6 times 10 to the power 6. Meters to meters cancel out, that is, don't write it, don't even bother writing it. 1.19 times 10 to the power minus 3. I wrote all the numbers. Okay, and this is in lobes, but I don't need it in lobes. I want it in kilograms, so I need the kilograms to be on top, lobes to be at the bottom. Okay, and here's the relationship, guys. Here's the relationship. 1 kilogram is 2.205 lobes. Okay, 1 kilogram is 2.205 kilograms. Okay, so basically 1 kilogram is what? 2.205. Okay, so you do the math and then figure out the answer. Okay, I don't have an answer on us. I mean, I don't have a calculator. Well, let me try to use my phone. So by the way, if you're using a phone, you can tilt your phone horizontally, and then it will give you a scientific calculator, which is very useful in doing these type of calculations. So I will cancel out 10 to the power minus 3 with this. Okay, so 8.84 multiplied by 6 multiplied by 1.19 divided by 2.205. Okay, 2.205, and then multiplied by 1000. Okay, and you will get the answer. Okay, that is how you do it. Alright, so that is a lot of cable, but it is 2.8 or 2.9, you can say, times 10 to the power 1 kilograms. Okay, so use a calculator. It is very important using a calculator. Okay, yep, so it's 28.6 or something. Okay, so you can say it's 29, around 20. I mean, use the significant figures and then figure out the answer. You have 3 sig figs in here. Yeah, so your answer will be in 3 significant figures, so you can say it is 28.6 kilograms. 28.6 kilograms. Okay, you can say that it is 28.6 kilograms. I don't know how to erase this, so yeah, I mean, you get the idea, right? So here's the solution. This is not it, definitely not it. Let me erase this ink. So this is the plan. If you want to pause and figure out the plan, be my guest. So this is the length of the cable in one strand, and then you convert it into, I mean, it's a little bit different than what I did, but I mean, they're converting the length into meters first. Okay, so you first convert the kilometers to meters, and then you multiply the mass by lobes, but of course you have to multiply all these things by 6 because you have 6 fibers in a cable. Okay, and then finally once you have that, convert it into kilograms. Okay, so these the kilograms to lobes to kilogram conversion, and you will get the answer. All right, did I have an answer or just okay? 2.86. Okay, 2.86 times 10 to the power 4 kilograms. 10 to the power 4 kilograms. Okay, so this is the answer. Okay, this is the answer. So if you want, you can write it down, pause the video and write it down. And here's another calculation we can try right now. Okay, let me yeah. All right, let me explain this to you. Hopefully you can pause the video and then do it before I do this. Okay, what you have is a lithium slab. Okay, and the mass is given, which is 1.49 times 10 to the power 3 milligrams. Okay, and you can convert the milligrams into grams, so it will be 1.49 grams. Okay, you know the mass of your lithium slab. Okay, how did I do that? I used the relationship between milli. Okay, milli is what? 10 to the power minus 3. So what you need here is to get rid of milli, so the conversion factor should have m at the bottom or milli at the bottom and 10 to the power minus 3 at the top. Okay, so use this conversion factor and you will get the answer. And let's see. The dimensions are given. Okay, so let's draw a nice little piece of lithium. Okay, all right, so this is the lithium slab that we have. Okay, one side is 20.9 millimeters, and then let's say this side is 11.9 millimeters, and this side is 11.1 millimeters. Okay, so this is the size of the slab. This is the size of the slab, and then they need us to calculate the density. Okay, density is calculated by mass divided by volume. This equation should be remembered. This is important. Okay, and mass should be in grams according to these units. Of course, mass should be in grams and volume should be in cubic centimeters. Okay, so we already have the mass in grams, which is 1.49 grams. We need the volume in cubic centimeters. So since we need the volume in cubic centimeters, I mean, to calculate the volume, what you do is you multiply the three length measurements. Okay, so I mean, they are given in millimeters, so you might want to convert them into centimeters. How do you convert millimeters into centimeters? You divide it by 10. How do I know that? It is very straightforward. Okay, why? Because milli is 10 to the power minus 3, centi is what? 10 to the power minus 2. So the difference is how much? 10. The difference is 10. Okay, so of course centi is a bigger unit, 10 times bigger unit. So when you measure the same length by a 10 times bigger unit, you simply divide the value by 10. Okay, so L1 will be 2.09, L2 will be 1.19, and then L3 will be 1.11. Okay, so this will be in cubic centimeters. Okay, alrighty, so let's punch these numbers in our calculator. 2.09. Of course, you have to have a calculator in the exam. Okay, don't use a cell phone in the exam and then you will get in trouble. Okay, 2.76. Okay, 2.76. Okay, so double check these calculations because I'm doing it. I mean, I just got my calculator back, but I mean, double check these calculations. And then density is what? 1.49 grams divided by 2.76. Okay, so 1.49 divided by 2.76, and what I got was 0.540, okay, grams per cubic centimeter. Hopefully this is the same that I have in the answer, otherwise I did a calculation error, but you can't see, of course. Let me erase the ink. So this is the plan, okay, but I think I already explained it. You will figure out the gram value, and then you will multiply the lengths by each other to get the volume, but of course convert millimeters into centimeters first, okay. So far so good. That is the same cubic centimeter volume that we got, so density will be that, yeah, 0.540. all right, same answer. All right guys, with this I'm going to conclude the video. I recommend that you guys practice some more problems on converting SI units and converting between SI units and US units, and then if you have any questions, please let me know, okay. You guys have a good one. Take care.